Assalamu alaikum, Fahad. Assalamu alaikum, Miram. Please write these questions, guys. You have to classify the following as positive, negative, or zero overlap. Hello, Devangi. How are you?
Good evening, sir. I'm fine.
Good evening. आपने लास्ट लेक्चर देखा क्या देवांगी?
No, sir. My half yearlies were going on.
So it's still going on. Okay. So you may not be able to do this question, but आगे के टॉपिक्स आपको समझ में आएंगे. Okay.
Yes, sir.
Okay, so we'll see. Iram, waiting for your answer. Iram, आपसे हो रहा है? You're doing this? Yes or no? Tell me.
Yes, sir.
Okay. Yes, Iram, send the answers, whatever you have done.
Yes, I'm sending in the chat.
Okay. Okay. So let us see here. So when different faces, though, they will overlap with each other. So we can have here, this is my negative face, this is positive face. Okay, so this is going to give you negative overlapping. Okay. Second one, negative and negative, both are same. Then this is going to give you positive overlap. Okay, it should be same. Negative, negative, positive, positive. So this is positive overlap. Positive, negative, positive, negative. This is going to be negative overlap. Here, as you can see, positive is also overlapping with some positive part and it is overlapping with negative part. So it will cancel out each other. You will get here zero overlap. And similarly here also, positive is overlapping with some of the negative and some of the positive. This is going to give you zero overlap. Okay. So the first one was negative. Let me see the answers now. Negative, positive, positive, negative, not sure, and then zero, zero, zero. Huh. So yeah, Iram, you're correct. Fahad, your answers are correct. I hope you understood for the fifth one also. Yes or no, Fahad? Fahad, did you understand the fifth one? Oh, okay, fine, fine, fine. Got it, got it. Okay. Now please write. Okay, by the way, Devangi and Abdullah, you understand that what orbitals these are? This is p orbital, yes or no? Do you know this, Devangi? This is the s
Yes, sir.
orbital. Achha, achha.
Yes, sir.
Okay. Okay. So now you write the topic. अभी हम लोगों ने क्या पढ़ दिया? Overlapping पढ़ दिया. Okay, fine. Yeah. So now we need to learn about the formation of sigma bond and the formation of pi bonds. Please write the topic. Formation of what? The formation of sigma bond. Okay. So for the formation of sigma bond, we need to have, see, each and every bond will be formed by the overlapping of two orbitals, and the overlapping of two orbital in how it should overlap? It should overlap positively. Okay, it should overlap only positively. So please write first of all. The first point, how the sigma bond forms. Same atomic orbital. Now same atomic orbital with respect to the axis. Overlapping on the same axis. forms sigma bond. Forms sigma bond. Okay. देखिए, for example, if you have px, ठीक है, आपके पास क्या है, सिग्मा बॉन्ड बनाना है आपको किससे, px से. Can we make any bond with one atomic orbital? Tell me guys, can we make any bond with one atomic orbital? Yes or no? अरे जल्दी
No,
बताइए.
sir.
वेरी गुड. ओके. फहद, क्या हो गया आपको, साइन लैंग्वेज में बात करेंगे क्या आप? ओके. Now, first sigma bond, we need the same orbitals. So if I am taking this as px, okay, with respect to axis, this is also going to be px. So you can see that it is p. I'm not saying that the atomic orbitals should be same. I'm just saying that with respect to axis, it should be same. Okay, x and x. That means their lobe should be on the x-axis. Now both the lobes are on x-axis and they are overlapping on what? They are overlapping also on the x-axis. They should be overlapping on which axis? They should be coming together in the x-axis like this. So this is going to give a sigma bond. Okay, this is going to give a rise of sigma bond. So this is the overlapping. Yeah, tell me.
So could you repeat the sentence, please?
Repeat the sentence. You have to take. आप इसको लिखिए, हम और एग्जांपल से पूछेंगे, फिर आप आंसर कीजिएगा, ठीक है? You write this down. I will tell you. This axis is x-axis. You wrote this down, Iram?
Yes.
Okay. Now let us say, for example, you have py. I'm drawing this py like this. Okay, this is your py. Okay. Now you tell me here, what is the another atomic orbital that I should have in order to make a sigma bond?
Py?
Py only, right? Very good. And they should overlap on which axis?
Y?
Very good. ठीक है, बात समझ में आ गई? They will overlap like this. This is the axis of overlapping. Okay, so this is the axis of overlapping, and you are going to get because this is the bond that we have formed. This is the bond that we have formed. Similarly, if you have s orbital, now, अब आपको याद होगा, like we have said that s is non-directional in nature. That means it does not have any direction. So this s orbital, it can overlap with any orbit. Okay, so if it is overlapping with, let us suppose, px on the x-axis, किसके साथ overlap कर रहा है? Px on the x-axis. So it is going to give you what? It is going to give you a positive overlap like this. अच्छा, one more thing, the phases should be same, है ना? तभी bond बनेगा. All the bonds are formed by positive overlap only. Okay, and then I'm going to use the same thing. Okay, if here it has positive, positive, and negative. Now this axis is going to be what? This axis is going to be your px. Sorry, this is your x-axis, and this orbital is going to be your px. Got it, guys? Yes, please tell me. Okay. Now, this is the true definition of a sigma bond. Okay, but in your exam, you are going to write it like this. We'll ask you what is a sigma bond and how it is formed. So you'll write the bond formed by direct or axial overlap direct or axial overlapping between two atomic orbitals. Is called sigma bond. Got it, guys? Please tell me. Yeah. Can I move on? आगे बढ़े? Can I move on?
Yes.
Okay. Right, next. The pi bond. Formation of sigma bond लिखा था हम लोगों ने. Second लिखिए formation of pi bond. Okay. In this, what happens? You'll have same atomic orbital with respect to axis. ठीक है? With respect to axis overlapping on a different axis. Okay, so for example, the best example will be this is my x-axis. Okay, this is my x-axis, and I have py orbital. है ना? ये आपका x है. This is my py. This is my py. Positive, positive, negative, negative. है ना? So we have same atomic orbital with respect to what? With respect to axis, right? And they are overlapping on a different axis. Y वाला किस में overlap कर रहा है? X में. And you are going to get what? Something like this. So positive, positive, negative, negative. Okay, so this is a pi overlap, and it is the formation of pi bond. Similarly, you can have something else also. This is known as p pi overlap, because the two p orbitals are making what? The two p orbitals are making pi bond. There is another one which is known as p pi d pi. So you'll have one p orbital like this and any of the non-axial d orbital. Okay, so this is one of the d orbitals. And what is happening? You have plus and minus. The d orbitals are like this. And when they are going to overlap, they are going to form what? P pi d pi overlapping, and this they're going to form a pi bond. P pi d pi overlap. This is your x-axis. Okay. And there's another one which is known as d pi overlap. Okay, and they are like this: positive, positive, negative, 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 positive, and positive. And when these are going to overlap with each other, they're going to form a pi bond, and that pi bond will be made by the d orbital. That is why it is known as d pi overlapping. Done, everyone? Yes or no? Please tell me. Is
Done.
everyone done? ठीक है, अब देखिए एक चीज हम आप लोगों को समझाने जा रहे हैं, उसको ध्यान में रखिएगा कि ऑल ऑफ दीज बॉन्डिंग्स दे हैपन किस तरह से ये होता है, ठीक है? सो कीप दिस फ्रेमवर्क इन योर माइंड. आई एम टॉकिंग अबाउट नाइट्रोजन नाउ. Nitrogen is 1s2, 2s2, 2p3. Okay. Now here nitrogen, it is going to have, what is the valence shell here? The valence shell is 2s2 and 2p3. Na? So I'm going to form, this is 2s2 and this is 2p3. 1 and 2 electrons here, 1 electron here, 1 electron here, 1 electron here. That means px is having 1 electron, py is having 1 electron, and pz is having 1 electron. Is everything clear till here? Yes or no? Please tell me, guys. Devangi, Iram, Fahad, and Abdullah. You know what is the structure of nitrogen now. Nitrogen has 3 unpaired electrons. And if you remember the valence bond theory says that the bond is formed when two atomic orbitals with 1 electron in each of those atomic orbitals, they combine, right? They are going to combine. So please see how this complete nitrogen N2 molecule is formed. How this N2 molecule is formed. Okay, so I'm going to make one lobe like this. Don't have to write anything. Okay. This is your P. You can say this is your Py. This is another. Okay, this is another p orbital. Can all of you see that? Sub nitrogen mein hi hai. Nitrogen will have 3 p orbitals, right? So all of these are in nitrogens only. I should make it a bit lengthier. And then there is going to be one more. I'm not really sure how to make that. I can rotate it only 90 degrees, nothing else. Oh, that's sad. Okay, so I have to make one more. Okay, now see what I'm going to say. You have to choose one axis. Like this is one nitrogen molecule. This is one nitrogen molecule, okay, which is having one electron and px or y, you can say one electron here with up spin and one electron here with up spin. The same thing is going to be there in another nitrogen molecule. But with down spins. Okay? Okay, guys, yes or no, please tell me till here. Can all of you see that this is one nitrogen, this is blue nitrogen atom, and this is the red nitrogen atom. And I have drawn these p orbitals. Iram, Fahad, and Devangi, please tell me, are you
Yes, sir.
understanding till here? Okay. Ab dekhiye, when they are going to come close, they have come close. Now, as you can see, this bond here, this bond here, this is your sigma bond, correct? Because this was your axis, na? Ab dekhiye, kya hua tha? Look at the axis. Look at the axis, guys, okay? See? The axis in which it is traveling, it is overlapping, it is the same axis. That is why this is your sigma bond. Okay, and the rest of the two, the bond between this orbital, and the bond between this orbital and this orbital. This is going to be your pi bond. This one and the red one is this one. Both of these are what? Pi. Pi bond. This is also your pi bond. All of you understood this? Yes or no? Please tell me. The formation of nitrogen in two molecule. What are the sigma bonds and what are the pi bonds and how they are formed?
Yes, sir.
What about Iram and Fahad? Yes, Iram, आपको आया? नहीं आया?
हाँ सर, आया.
इतना टाइम क्यों लगता है? नहीं आया तो आप बता सकती है ना क्या हुआ? Like, I don't understand this. Yes, Iram, tell me.
सर आया समझ.
Okay. So this red one here. Now what we have to do? We have to choose which axis it should be, right? Which axis it should be. So the internuclear axis we say. Why internuclear axis? Because there are two atoms, and each atom will have a nucleus, right? And these nucleus will come together, and they are going to come together, and that is why the overlapping of orbitals are going to take place. So the atomic identity is there in the nucleus only. Nucleus has the number of proton, and the number of proton decides which element is this. That is why we say that the nuclei is coming together. Okay, the nuclei is coming closer, and due to that only what is happening, the overlapping of orbital is happening. Now, when that happens, we should have to choose a internuclear axis. Internuclear axis, right? There should be a axis in which we will say that this is the axis in which the nuclei they come close together. So the internuclear axis that was chosen was the z axis. Okay, the internuclear axis that was chosen was the z axis. Please write internuclear axis is z axis. Is z axis. Okay, what does it mean? It means that if px and px are overlapping, then it will form pi bond. Q. Why it will form pi bond? Because they are overlapping over the z-axis. Now we have taken the z-axis as a common axis in which all the atoms, we will say, now this is a convention. Okay, this is we could have taken anything, but in NCERT also and in chemistry, the z-axis is the internuclear axis. That is why if px and px are overlapping, then it is going to form the pi bond. Similarly, if py and py are overlapping, then it will form pi bond. But when pz overlaps with pz, then sigma bond is formed. Okay, then sigma bond is formed. So guys, just now please tell me, is everyone done? Fahad, can you please turn your mic on? क्या समझ नहीं आया?
सर ये px py pz।
हाँ, तो बताइए कौन से एक्सिस में ये लोग मिल रहे हैं? Which axis? Tell me. What is the axis? Atoms overlapping जो होती है atomic orbital की, वो कौन से एक्सिस में हो रही है? Z एक्सिस में हो रही है, ठीक है। आपका हम Z एक्सिस बनाते हैं इस तरह से, ठीक है। Just for the sake of argument, this is like it is completely convention ना कि आप Z axis किसको लें. I'm saying this is the Z axis. So obviously the px will be 90 degree to Z. Yes or no? Please tell me.
Yes.
ये px है, ठीक है। ये px है, कौन सा बॉन्ड बन रहा बताइए? इस पर
सर मुझे पाई बॉन्ड समझ नहीं
पाई बॉन्ड
मतलब
नहीं है।
ये जैसे जब मतलब समझ नहीं आया।
जैसे और मतलब क्या समझ नहीं आया बताइए? क्या है पाई बॉन्ड की डेफिनेशन, क्या है बताइए?
वो भी समझ नहीं आया।
वो आपको क्या है, हम रीड करने के लिए बोल रहे हैं।
पाई बॉन्ड का नहीं लिखा मैंने।
नहीं लिखा आपने?
नहीं।
तो लिखिएगा तब तो कुछ आएगा। लिखिएगा तब तो कुछ आएगा, आप लिखिएगा नहीं तो फिर कहाँ से आएगा? ये लिखा नहीं है आपने, सेम एटॉमिक ऑर्बिटल विद रिस्पेक्ट।
हाँ ये लिखा।
हाँ तो बताइए ना क्या है वो? सेम एटॉमिक ऑर्बिटल विद रिस्पेक्ट टू एक्सिस x है, राइट?
जी।
और ओवरलैप कहाँ कर रहा है? x में कर रहा है या किसी और में कर रहा है?
नहीं तो हमें कैसे पता किसमें ओवरलैप करता है?
क्या 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 वही वही, हाँ बोलिए, हाँ आप बताइए।
हमें कैसे पता किसमें ओवरलैप कर रहा है?
हम बोल रहे हैं ना z एक्सिस है, वो आपको दिया रहेगा कहाँ ओवरलैप कर रहा नहीं कर रहा है।
ऐसा अगर हम इसी p ऑर्बिटल को 90 डिग्री टर्न रखें तो
दोनों को
दोनों
टर्न कर दो, यानी कि आप z एक्सिस मतलब pz बनाना चाह रहे हैं, राइट?
जी।
ये pz हो जाए। अगर ये एक्सिस है इस तरह से, ये z एक्सिस है, if this is your z axis then this is going to be pz ना?
जी
ठीक है। अब बताइए क्या बनेगा, पाई बनेगा सिग्मा बनेगा?
सिग्मा
सिग्मा, है ना? क्या दिक्कत हो रही है बताइए अब।
अच्छा ओके ठीक है समझ गया
समझ में आ गया?
जी।
ठीक है, अब भले
ये
ही
सिर्फ
आपको शायद, हाँ
ये सिर्फ
बिल्कुल।
पी से रिलेटेड है ना, अगर हम जैसे वो बनाते
नहीं
हैं
नहीं,
एस।
एस तो, एस का कोई डायरेक्शन नहीं होता ना।
हाँ
मान लीजिए आप अगर एस बना रहे हैं, तो ये एस और ये एस दोनों विद रिस्पेक्ट टू डायरेक्शन सेम ही है, राइट?
जी। और डी में
आप
क्या होगा?
किसमें, डी में? डी में
जी
आपके पास क्या है बताइए, कौन कौन से एटॉमिक ऑर्बिटल्स आपके पास एक्सियल हैं और नॉन एक्सियल्स हैं, राइट?
जी।
ठीक है, अब बताइए देखिए, एक आपको हम एक सबसे पहले आप डीजेड का देख लीजिए। ये डीजेड कुछ इस तरह से होता है, अगर हम ये जेड एक्सिस को मान ले तो, सही है, डीजेड
जी
स्क्वायर। दूसरा डीजेड स्क्वायर आएगा यहाँ पे, कौन सा ये बनाएगा बताइए?
सिग्मा।
दे आर ओवरलैपिंग लाइक दिस, हाँ ये सिग्मा, जी। अरे
सिग्मा सिग्मा।
सिग्मा है ना, बस
जी
ठीक है। दूसरा दूसरा क्या है बताइए? डी,
डी।
स्क्वायर माइनस वाई स्क्वायर, यहाँ पे देख क्या बनाएगा।
ये कौन सा एक्सेस है?
दिस इज योर, लेट अस से दिस इज योर एक्स एक्सिस, मान लीजिए, चलिए थोड़ी ये एक्स नहीं है, ये आपके पास जेड एक्सिस है। जेड एक्सिस लेकिन ऐसे नहीं होगा, फिर एक सेकंड, थ्री डी में इसको थोड़ा सा दर्शाना मुश्किल होगा, लेकिन बट आई एम जस्ट ट्राइंग, वेट अ सेकंड। अब समझ में आ रहा है आपको, ये जेड एक्सिस है,
जी समझिए।
ठीक है। आप इसे बताइए कितने ऑर्बिटल का ओवरलैपिंग हो रहा है?
फोर्थ।
चार का
मतलब
हो रहा है, हाँ हाँ चार का हो रहा है, बिल्कुल
नहीं,
सही है।
फोर का कैसे
नहीं
होगा?
हो रहा है?
फोर्थ तो
चार का
लोब्स
नहीं
है
हो
ना,
रहा है?
ऑर्बिटल तो एक ही है।
हाँ, और हाँ, फोर लोब का ओवरलैपिंग हो रहा है, राइट?
जी
ठीक है, तो ये इसको बोलते हैं डेल्टा बॉन्ड। ये आगे भी होता सिग्मा पाई, उसके बाद डेल्टा, ठीक है। तो सिग्मा में आपके पास अगर देखिएगा तो वन लोब इंटरेक्शन है, पाई में यू आर गोइंग टू हैव टू लोब इंटरेक्शन, इन डेल्टा यू आर गोइंग टू हैव फोर लोब इंटरेक्शन, गॉट इट?
ठीक है।
ठीक है, वैसे आपके इसके क्लास में सिर्फ और सिग्मा और पाई ही है, एंड दैट इज ओनली टिल पी ऑर्बिटल्स, पी से आगे भी नहीं है आपके इसमें। यू डोंट हैव टू लर्न लाइक वैलेंस शेल इलेक्ट्रॉन्स जो कि आपको देखने हैं, you have to just look for, you have to just study the p block, not the d block elements, okay?
ओके
Write this part, internuclear axis is z axis, and then px are overlapping, then it will form pi, py are overlapping, then it will form sorry, px pi, py pi, pz में overlap करेगा तो it will form sigma bond, okay? Then write a note. So one lobe interaction between two atomic orbital on INA. INA आपका क्या है? Internuclear axis. On INA forms sigma bond. ठीक है? Second, two lobe interaction between two atomic orbital above and below ion forms pi bond. Delta bond क्या होता है? When you have 4 lobe interaction between two atomic orbital above and below ion forms delta bond. Done, guys? Jason, please tell me.
Yes, sir.
Okay. All right, next, some remarks regarding pi and sigma. The number one point is, देखिए, if you are making a sigma bond, okay, if you are making a sigma bond, you can rotate both the atomic orbitals. Okay, you can rotate the atomic orbitals. Think about it like this. Wait a second. Okay. What you should do is to touch your fingers like this. There is an emoji ना? क्या emoji है? Where you touch your fingers. Yeah. Okay. So this kind of signifies your sigma bond, right? They touch, they overlap like this, right? Listen, please tell me. Okay. And what you should do while you are touching one of your both the fingers, try to rotate one of your hand. Try to rotate the wrist. As you can see, the bond is still formed. Like the bond is not breaking. Yes or no? Even if you rotate your hands. No. Yes. Tell me, guys.
Yes.
And a bond नहीं टूट रहा है. That's the only thing. Okay. Then, you know how to make diamond with your hand. How to make
Yes,
diamond
sir.
with your hand? जो diamond push-up में करते हैं. Diamond with fingers. Yeah. अरे ऑल ऑफ यू नो या नहीं पता? हम बना के दिखाएं आप लोगों को, ऐसे कुछ होता
जैसे
है ना।
वो काइट जैसा शेप बनता है, डायमंड तो नहीं।
हाँ मतलब इस तरह से होगा। दिस इज योर forefinger, this is your thumb, and this is another forefinger, this is your another thumb, and then your hand is like this, right? Correct? अच्छा, अब यहाँ पे आप क्या कीजिए, you try to rotate one of your hand, you will see that the bond is breaking. Can you see that? If you try to rotate,
Yes.
right? So see, that means rotation is allowed when you are having sigma bond. Okay, and this is something that we are going to use in organic chemistry. ठीक है, यहाँ पे लिखिए, this is very important point. Rotation along internuclear axis is allowed. Allowed का मतलब the bond is not going to break if you are rotating. Is allowed in sigma bond. Rotation. Oh, this should be along. Along INE is not allowed in pi bond. Next point. Pi bond forms only
See?
after the. Yeah, tell me.
So the
बोलिए
first
सर।
point is sigma है ना?
हाँ, ये सिग्मा है
पहले।
ना, सिग्मा ऐसे लिखते हैं ना।
हाँ, वो
This is a sign for sigma.
yes.
ठीक है, आपको क्या लगा ये सिग्मा?
नहीं नहीं, वो मुझे थोड़ा अजीब सा लग रहा था, अलग कुछ।
अच्छा, ये पता है दोनों में क्या फर्क है?
वो समेशन।
नहीं नहीं अरे नहीं, तो ये दोनों सिग्मा कैसे, दोनों को सिग्मा क्यों बोलते हैं? Pi bond forms only after the formation of sigma bond. ये आपका अपर केस है और ये आपका लोअर केस सिग्मा है। ठीक है, अपर केस सिग्मा है वो, ये आपका लोअर केस सिग्मा है। Okay, so and obviously this is also quite logical because first of all the orbitals which are on the axis, they are going to overlap first, and then only the other axis which are lateral, they are going to overlap. Okay, I think pi का हमने एक definition नहीं लिखा। अच्छा, write a question, उसमें हम लिखा देते हैं आप लोगों को। How is pi bond formed? Please write. The bond which is formed by sidewise or lateral overlapping between two atomic orbitals is called pi bond. Then everyone, yes or no, please tell me. Is everyone done?
Yes.
Done, sir.
Okay, right, next. Strength of sigma and pi bonds. Please write the first point. Sigma bonds are stronger than pi bonds. Why? Due to greater extent of overlapping. Greater extent of overlapping in sigma bonds. We have written it earlier also. As the extent of overlapping increases, the strength of bond is also increases. Okay, so this is the first point. First point हम लोगों ने क्या सीखा? Sigma is pi. Sigma is stronger than pi. If you get a question, compare the bond formed by following along the internuclear axis. यानी कि Z axis के along there are some bonds which are forming. Number one, if you are forming Px and Px, if they are joining and they are forming, then this is going to form what? Pi bond, right? Secondly, if you are having Pz and Pz, then it is going to form what? Sigma bond. Right? Px weaker than Pz bond. Please remember, along what? Along internuclear axis, that is Z axis. But if I am asking the question along this X axis, if I am asking, then in the X axis, the Px is going to be sigma. ठीक है? लेकिन internuclear axis आपका Z है. अगर specify नहीं किया है तो आप लोग हमेशा क्या लीजिएगा? You will always take Z as the internuclear axis. Okay. Write this down. Done, guys? Yes, no, please tell me.
Yes, sir.
Okay. Let's do some question now. Now we are going to compare different types of overlapping. Okay, and we are going to go into details of overlapping. Positive, negative we have seen, and now we are going to deal with what we are now going to deal with the concept of overlapping with respect to what? S, P, D, and F orbitals. Okay, S, P, D, and F orbitals. So please write concept of overlapping. Okay, now the overlapping or the extent of overlapping or the comparison, if I am going to make, then first of all, I can say that there are three things that you have to see. First thing is that the size of orbital. First of all, right? Size of orbital. Effective overlapping. It is inversely proportional to the size of atomic orbital. If the atomic orbital is what? It is small. Okay? If the atomic orbitals are small, that means all the electrons are very near to the nucleus. But if they are large, then there will be far away from the nucleus, and that is why the extent of overlapping will not be good. That is why what happens, the size of atomic orbital, if it increases, then we say that the extent of overlapping decreases. Okay, effective overlap is inversely proportional to size of atomic orbital. Hence, if I compare 1s overlap with 2s, then 1s will be stronger than 2s, and this will be stronger than 3s. Similar is the pattern for 2p, because p orbital starts with second shell only. So we'll say 2p is what, having effective overlap, more effective overlap than 3p, than 4p. Okay, and so on. Now, there's another thing that we have to see. That is the directional nature of overlap. This is right next, directional nature. Directional nature. Okay. Now, effective overlap. Let me just bring this here. Effective overlap is directly proportional to the directional nature. Okay, is directly proportional to the directional nature, and we are just going to compare the S and the P. So 2s if I compare with 2p, if I compare 2s overlap with 2p overlap, then in this case 2p is going to win. Why it is winning here? Because the n is same. N is same. The size is not increasing. It is second shell. It is also second shell. The distance between the nucleus is not changing, but P is directional in nature. P is committing, and it is committing towards one direction. It is overlapping completely on that direction. And S is what? S is not committed to one direction. It is what? It does not have any direction at all. It is directionless. So when P is overlapping on the x-axis, all its orbital is on the x-axis, but it is not true for the S case, right? It is not true for the S case. Then the next thing is diffused. You have to also check if the overlapping is between diffused or it is with a concentrated atomic orbital. So effective overlap is inversely proportional to diffused. And that is why if I compare 3s, then 3s is going to have higher than 3d. Because D and F atomic orbitals are what? D and F atomic orbitals are diffused. That means they are very much spread over. Okay, they are spread over very much. If you look at S, it is concentrated. P is still concentrated along one axis only, but D, it is there. It is not in one axis, rather it is everywhere. Okay, so that is why D and F, these are diffused.
But sir, 3D would also be directional in nature. So shouldn't its effective overlap be greater than
नहीं, लेकिन
3?
देखिए ना, वो एक डायरेक्शन में कहाँ कमिटेड है ना? It's not committed in one direction ना?
जी ठीक
है ना? इस वजह से फर्क है दोनों में, P और D में. ठीक है? So these are the things that we have to see. Okay. Now, right next. Comparison of, लिख लिया आप लोगों ने ये? This is between S, P, D and F. Okay, so obviously F को आप लोग छोड़ दीजिए, F का सबसे weak होता है. Okay, this is about S, P and D. Now let us look inside that also. Okay, please write comparison of extent of overlap. Overlap ज़्यादा होगा तो bond strong होगा. This is something that you have to just keep in mind. Now, whenever you are comparing, you will be given some atomic orbitals, okay, that you have to compare. 2s का 3s से, है ना? 3s का 2p से, इस तरह का अगर आपको दिया जाए तो, Now, if you have different shell, if the shell number is different, then what you have to see? Effective overlap is inversely proportional to n. What is n? It is the principal quantum number. Okay, it is the principal quantum number. Got it? That means lower the shell number, more effective is the overlap. ठीक है, अगर आपके पास क्या है, डिफरेंट शेल है, तो आप किसको प्रायोरिटी दीजिएगा? शेल नंबर को। आपको वहां पे फिर देखना ही नहीं है कि आपके पास एस है या पी है या क्या है। ठीक है, गॉट इट गाइस? यस और नो? प्लीज टेल मी। अब देखिए, when you have same shell, then what you have to see, this is the order NP is going to be the most effective overlap, followed by NSNP, which is followed by NSNS, which is followed by NDND. ठीक है, तो यहाँ पे हम केस लेते हैं किसका? 4 का. So if you have the 4p overlapping will be most effective than four S4p, then will be the number of 4S, and at last you'll have 4D. Similarly, you can also write 3p will be most effective, followed by 3S3p, followed by 3S, followed by 3D. Okay guys, 3p में क्यों है? Because directional in nature, है ना? And 3S3p again directional in nature. Then we have 3S, and after that we are going to have 3D. Why? Because it is diffused in nature. Done everyone? Is on? Please tell me.
Done, sir.
Done guys? Okay. Right, next question. Compare the bond strength. Compare the bond strength of bonds formed by overlapping of following. Okay, so you have been given 2s को आपको कंपेयर करना है. Then you have 2p, then you have 2s2p, then you have 1s, then you have, चलिए इतना ही देखते हैं. ठीक है, let's compare these four. First of all, what you are going to see, are all of the shells, are all of them same or they have some different? बताइए. This is the bond formed by A, this is your B, this is your C, and this is your D. A, B, C, D में बताइए, is the shell number changing anywhere or is it same everywhere? Tell me guys. In A case, हाँ सर बताइए, different है same है? Different है. कौन सा different है A, B, C, D में? D is different. Okay. Is it smaller than others or it is larger than others? नहीं, size की बात.
smaller है तो ज़्यादा effective.
So D is most effective. Now, rest all of them are what? Same, right?
Yes sir, same.
तो फिर उसके बाद सबसे ज़्यादा किसका होगा? NP. That means B will be the strongest after that. Then you will have NSNP. That means C. And at last, we'll have the A case in which we are having 2s2s. Okay, so this is the order. Got it, guys? Yes or no? Please tell me.
Yes.
Okay, now see. Next one. Compare the bond strength. Following. Okay, so if you are going to have CC bond, sigma bond, okay? Then you have NN sigma bond, then you have OO sigma bond, and then you have bond between fluorine and fluorine. Okay, now we have to compare. Now see, carbon, what is the electronic configuration for carbon? Valence shell कौन सा है इसका? Valence shell में कौन कितने इलेक्ट्रॉन है? Think about those things. Atomic number, atomic numbers, electronic configuration. So you will say that okay, fine. The 2p orbital here, right? Yes or no? The 2p orbital is having unpaired electrons, right, guys? Yes or no? Please tell me. 1s2, 2s2, 2p2, right? So the 2p orbitals are having unpaired electrons, and they are going to form bond. And also you can say that because all of these are in p block elements. So valence shell या फिर valence आपके पास subshell जो होगा, that will be always p. So here also it is 2p 2p, right? The bond is between 2p 2p. It is also between 2p 2p. Here it is also between 2p 2p. Here also it is between 2p and 2p. Now how are we going to compare? How are we going to compare here? See, first thing is that let us see how many electrons are there. So carbon has 6. Okay, in the valence shell it has how many? In the valence shell it has 4. So this carbon has used one of its electron for the bond formation. How much is remaining? There will be 3 remaining. So I will draw the 3 like this. Now this carbon atom will also have, it's using 1 electron to form the bond. There are 3 remaining. If I do the same thing with nitrogen, nitrogen is having 1 electron here, and it has 5 electrons in the valence shell. So there are, these electrons are remaining. It is there. Similarly, here it is going to have 1 electron here, and the rest 4 are going to be here. For oxygen also, it is going to be the same thing. 1 electron is here. 6 electrons are valence, and I have made the 6 electron like this. Okay, we are just comparing the bond strength. Okay, you don't have to worry about whether oxygen is happy or not happy, whether its octet is complete or not complete. Okay, we are just comparing the bond strength. Okay, and then at last we are going to write for fluorine. Now, fluorine is one of the elements which is quite unfortunate, and it's like very tragic for fluorine. Now, as you can see, carbon is what? Carbon is having 2p 2p, but it does not have to deal with much electronic repulsion. If you are going to have electrons in the vicinity, they are going to repel each other, right? So if you compare here, carbon has the least number of electrons than nitrogen. Then nitrogen electronic repulsion will be even higher. Then oxygen may even higher. Then in fluorine, it will be very high. So the comparison would lead to this trend. The carbon-carbon bond, single bond, okay? Sigma bond of carbon-carbon is most stable, or we can say it is most strong, followed by nitrogen, followed by oxygen, and then followed by fluorine. Then this is your A part. And उसके just नीचे आपके पास क्या होता है? Just below carbon, we have silicon. So silicon. Then here we have phosphorus, single bonds, okay? Sigma bonds only. Here we are going to have sulfur bond, and here we are going to have chlorine and chlorine bond. Now you will understand the pain of fluorine. Now, if I compare the silicon, this is 3p 3p. This is also 3p 3p. This is also 3p 3p. This is also 3p and 3p. Because all of them are in the third period, it is going to have the 3p subshell with the valence electron. Now, in this case, if you are going to see what is going to have the most, what is going to have the strongest bond strength. Okay, Now here you tell me what happens if I go from silicon to chlorine to the size. You will say that the size decreases. If the size is decreasing, that means size of atomic orbital also decreases, right? But you will say that, sir, आपने यहाँ पे तो चीज लगाई नहीं. Yes, because here the size does not matter. Here what is mattering? They are so small that the electronic repulsion is mattering, and that is why the second period elements are different. They have anomalous behavior. They show different behavior than the rest of their elements. So in this case, since we are going to have large atomic orbitals, the electronic repulsions are not going to play an important role. They're not going to play an important role, and that is why the size will be a dominant factor here. So chlorine is going to have the large size, followed by sulfur, and then followed by phosphorus. I have not even drawn the electrons because they don't matter here. Okay, because they don't matter here. Acha. But if I compare between carbon and silicon, since it is about 2p, carbon is going to have higher bond strength. Then nitrogen is also going to have higher bond strength. And between oxygen and sulfur, oxygen is going to have higher bond strength. But in fluorine, the size becomes so small. The size of fluorine is so small, and due to that small size, the inter-electronic repulsions, the repulsions between these electrons that are not bonded, it becomes so high that chlorine has higher bond strength than fluorine. Chlorine has higher bond strength than fluorine. Just a second, sorry, I think I messed up here. When you have more than 3, it is going to be like this. Sorry, this was my mess up. Okay, you have to remember this part. वैसे स्कूल में से तो बहुत, मतलब किसी भी स्कूल में हमने नहीं देखा आज तक इसके बारे में कुछ पूछते हुए. कभी कभार आपके पास जब कंपटीशन में एग्जाम में सवाल आ सकते हैं इसके रिलेटेड. Okay, so write this down. Now again, you have to remember this because it is based on what? Experimental data. Okay, this is based on data, and then we have some data, and then we come up with theory to explain it, why it is happening. क्यों हो गया फ्लोरीन का ज्यादा? फ्लोरीन का ज्यादा हो गया होगा क्योंकि इंटर इलेक्ट्रॉनिक रिपल्शन है. That's it. I write this down. Carbon में we have less number of electrons, and also what do we have? We have less number of electrons, and also we have larger size. That is why the inter-electronic repulsion is not very high. That is also one of the reasons why carbon can show such good property of catenation. Write this down, guys.
Done, sir.
Right. Question. अच्छा, पहले आप रिमार्क लिख लीजिए. If you have only single bond, if a molecule, if the number of bonds between two atoms is only one bond, if you have only single bond, that means this bond is going to be what? It should be sigma bond. Then if you have double bond between two atoms, then there is one sigma and one pi bond. And if you have a triple bond, this is going to be one sigma and two pi bonds. जैसा कि आप लोगों ने देखा था इसके स्ट्रक्चर में, N2 के स्ट्रक्चर में. Then guys, इसको लिखने के बाद सवाल लिखिएगा. Write a question. देखिए आपके पास ना ऑर्गेनिक कंपाउंड्स के कुछ इस तरह के मॉलिक्यूल्स दिए जा सकते हैं, CH double bond CH2. So please remember that this structure is like this: carbon with 3 single bonds with hydrogen, 1 single bond with carbon. This carbon has 1 single bond with hydrogen, a double bond with carbon, and this carbon has 2 single bonds with hydrogen. If I am going to count sigma, which I am going to count with red color, I will have 1, 2, 3, 4, 5, 6. Here यहाँ पे एक sigma भी याद रखिएगा, 6, 7 and 8, right? So there are how many sigma bonds? 8 sigma bonds. I'm going to count the pi with green, and this bond, one of the bond in the double bond is going to be your pi bond. So there is 1 pi. Got it, guys? Yes or no? Please tell me. Got this? Yes or no?
Yes, sir.
Okay. Similarly, look at the next question. If you have something like this, CH3, which is bonded to carbon with a triple bond carbon, and then CH3. Now this means you have carbon with 3 hydrogens, and then there is a bond with carbon. This carbon is having a triple bond with another carbon atom. Then this further carbon atom has a single bond with carbon atom with 3 hydrogens. Okay. Again, I'm going to count the sigma: 1, 2, 3, 4. Now this has 1 sigma bond. That is why 5, 6, 7, 8, and 9. Then I'm going to count pi. So there will be 2 pi bonds in the triple bond. And hence, I'm going to write there will be how many sigma bonds? 9 sigma. And how many pi? 2 pi. चलिए इस सी स्ट्रक्चर के लिए बताइए. देखते हैं देवांगी, देखते हैं. I think that is right, Devangi. That is correct. Also guys, you also write some homework. ठीक है, यही आपके असाइनमेंट में जाएगा इन CERT exercises chapter 4. You should do question number 4.28, 4.29, 4.31 and 4.32. बस 30 नहीं करना है. इरम, फहद, what happened guys? कोई आंसर नहीं है? इरम नहीं आ रहा क्या आपको?
सर मैंने आपको सेंड किया है।
कहाँ सेंड किया है? व्हाट्सएप पे?
नहीं सर, चैट में।
चैट में आपने लर्निवियो को भेज दिया लगता है, देखिए.
नहीं सर, मैंने
ओ
आपको
नहीं,
भेजा है।
अच्छा बहुत पहले भेज दिया आपने तो. हाँ सही है, सही है, वेरी गुड. फहद, व्हाट अबाउट यू? फहद, फहद है कि नहीं है?
फिर मैं भेज नहीं पाऊंगा, मतलब व्हाट्सएप नहीं है मेरे पास.
नहीं, आप चैट में भेजिए ना, कितने पाएंगे कितना सिग्मा है.
अच्छा अच्छा अच्छा.
बोल दीजिए, आप तो दोनों ने आंसर कर दिया. आप बताइए कितने हैं आपके इसमें.
सर
आपके
एक सेकंड.
अच्छा, एक सेकंड. जी बताइए, एक सेकंड. कीजिए कीजिए कीजिए, आराम से कीजिए. अगला क्लास जो होगा दैट विल बी वेस्पर थ्योरी. इरम, आपके स्कूल में ये चैप्टर चल रहा है, केमिकल बॉन्डिंग.
नहीं सर, ये हो गया,
खत्म कर दिया?
खत्म कर दिया।
तो व्हाट्स गोइंग ऑन नाउ इरम? आई थिंक स्टेट्स ऑफ मैटर तो नहीं है आपके सिलेबस में, राइट?
नहीं
स्टेट्स ऑफ
सर,
मैटर नहीं पढ़ा.